South Africa is a unique country. It is blessed with a wealth of biodiversity and diverse natural ecosystems, upon which many of its citizens depend for their livelihood. South Africa covers less than 1% of the world's land surface, but is home to almost 10% of the world's plant species, about 7% of the world's vertebrates, and 5.5% of all known insect diversity, making it a biodiversity treasure trove. However, the climate of the world is changing. Global warming is causing plants and animals to shift their distribution to stay within their preferred temperature range. The new threat of global climate change was recognized in the 1990s, and South African scientists with international collaborators have been studying the potential impacts of climate, atmospheric carbon dioxide, and land use change in our natural areas, spurred on by early projections of very dire potential impacts.
In the late 1950s, Charles Keeling invented a new way of measuring carbon dioxide in the atmosphere. He was really keen to try this out, but not in the polluted environment of cities, but in a remote area, and he chose Mauna Loa in Hawaii. And to his astonishment, what he discovered after a few years of measurement was that every year carbon dioxide in the atmosphere was increasing. So what possible relevance does CO2 in Mauna Loa have to us here in the Cape? Carbon dioxide is a greenhouse gas, one of the main contributors to global warming. Carbon dioxide is the main substrate for plants to feed on. And you change the carbon dioxide and you change the diet of plants. And what we're interested in is how this is influencing the nature of South Africa.
In the past 150 years, since fossil fuels began powering the industrialized world, CO2 levels have increased by more than 40%, causing extra heat to be trapped in the atmosphere and making the Earth's surface warmer.
Changes in the air, CO2 concentration really matters for plants, and they respond strongly to changes in CO2 concentration, but the response is species specific, and this means that we have to do experiments here under southern African conditions, looking at all the plant species that are important to us.
We are starting to feel the effects of an atmosphere and biosphere significantly changed by the byproducts of progress. Based on the research from many scientists, we are building up a clear picture of how natural areas of South Africa are changing.
We're in a climate here which has some of the highest rainfall in South Africa, and the dominant vegetation on the slopes there is low shrubby fynbos, and here you can see a patch of forest. The biggest changes in South Africa could be the shift from this low vegetation, grasslands or shrublands, into forest. And what we see in the Yonkeshoek Valley is the invasion of this area of the fynbos by pine trees.
Behind me we see a catchment which has been converted by people who've been planting trees into it. And this has big implications for the water use of this catchment. But in the summer rainfall area, these sorts of changes are taking place driven by rising CO2, and they have exactly the same implications. In other words, those vegetation types will also start to use more water, thus reducing the water flow to cities like Stellenbosch.
People believed on the one side that planting trees would bring more rain, and on the other side, irrigation farmers were complaining that when you planted trees, it dried up the rivers. And this experiment was the first in South Africa to explore that question by looking at how planting trees influenced the amount of water coming out of the mountains. By planting trees, you were drying out the rivers. Between 10 and 40% reduction of stream flow, so that all these mountains around us were planted up with pine trees. Cape Town would lose about a third of its water.
It is important to understand that the impacts of global change vary across the world, and a local perspective and local information is required to understand changes in our own areas, to project their likely outcome, and to plan accordingly.
We need to understand long-term changes in the environment, and one way to do this is to take historical photographs of 100 or 130 years and we go and stand in exactly the same place as where that original photograph was taken, and we retake the photograph and then interpret the changes in the environment and in the vegetation and try and understand what has happened to Southern African vegetation over the last 100-130 years.
These observations clearly show that over the last 15 years, increasing carbon dioxide has become a major contributor to vegetation change, and CO2 directly affects plant growth. So, let's take a look at some of the research being undertaken across the country.
In the past 50, 100 years, there's been enormous changes in vegetation across the South African landscape. Grass has been replaced by bush. And as you replace vegetation, you also change the available habitat for birds. And so the birds have been the quickest to respond to changes in vegetation. So we've lost the species, or losing the species, which depend on the big open patches of grassland within the savanna biome. Species like southern ground hornbill, secretary bird, and as the big grassy patches get bush encroached, they are subject to ambush predation.
We're looking at an old grazing area that probably 5 years ago they stopped ploughing it. You're getting small acacias coming in and actually invading these grasslands. On average, a cow needs about 50 kilograms of grass per day to survive, to keep the bacteria in its stomach alive, to just keep itself in enough of a condition. And if you look here, you can see there's probably not even a kilogram of grass that you could pick up in a hectare.
Africa boasted a wealth of browsers. These have been replaced by just one, the goat. Goats can be effectively used as one of the tools to combat encroachment.
The goats are able to change a lot of this brush into trees because they put enough pressure on the brush either to push it down and stop it growing, or once it starts growing, to actually push that canopy up into trees, which then are useful for both firewood but also help the area and the type of grasses that grow under the bushes become more palatable for livestock and last into the winter.
In the Namakaru, it was predicted that shrubs are going to invade the grassland biome, and what we've noticed is the opposite trend, with grasses moving into the Namakaru biome at a massive scale. The impact would be that sheep farming, which is traditional in the region, is going to be replaced by cattle farming. The increase in grasses also has major implication in terms of fire becoming a common occurrence, and that will affect biodiversity in the system.
Savanna landscapes need fire to maintain a tree-to-grass balance. Medium fire intensities remove the old moribund material and dead grass to allow for new shoots to grow to provide grazing for animals. High-intensity fires, or firestorms, are required to combat bush thickening and to reclaim the savannas and remove the woody vegetation.
Currently, the method to create a firestorm is to manipulate the weather and to burn under 30-30-30 conditions. We are now experimenting with alternative ways to create a high-intensity burn by burning under safer weather conditions, but then manipulating the pattern of ignition. And the one way where we're testing is by lighting a spiral ignition, where the pattern actually influences the vortex and getting an intense fire in an area where you want that intense fire to be. We are currently on a plot that has received fire every single year in winter for the last 50 years. It is a very hot fire that it does receive. What we can see is the landscape is much more open. There's a lot tree cover, the tree density is a lot less, but the grass composition and grass cover is much better on this plot than when you walk across on this side of the fire break, where this experiment or this plot receives a no fire treatment. And as you can see, the tree cover is a lot higher, the bush is much more denser in this plot, the grass cover and the grass species composition is also much poorer in this plot.
What we've seen in Shishlui is that if a normal fire comes through, the Dichrostachyses are fully recovered 2 years following the fire. When you look at the plants that have been burnt in the firestorm, even though they're beginning to resprout now, there's still a large part of the plant that's dead. and this has certainly slowed their recovery. This highlights the fact that firestorms can be used as an important management tool in controlling this bush encroachment problem.
The boundary between the savanna and the grassland biomes is being eroded by savanna trees, which are colonizing previously treeless grasslands. Trees shade out the grasses, impacting on commercial farming, as well as small-scale farmers in the rural areas of the country.
These hills behind me were open, rolling grass sods. And now, with this thorn tree, acacia karoo encroachment, it is making farming extremely difficult. I've had to change from small stock to large stock, and even that is a battle. This is our shearing shed, built in the 1950s, when we used to shear sheep and goats, Angora goats and merino sheep, when this was still grass sod. With this bush encroachment, I've had to get out of sheep and goats, and it's standing empty and is a building, no longer a shearing shed.
Wawuzofika isikhotha ngaphakathi emasimini, hayi ngaphandle, sasingesiningi isikhotha. Ubaba ukhona ebona utshani. Zikhona izihlahla kodwa lezi zemvelo, hayi imsasane ukuthi ayiminingi kangaka. Imsasane yashintsha ngoba inkomo ayibudli kahle umsasane. Imbuzi edla umsasane.
Now the bush is very thick, so we need a manpower to cut it down. We haven't got this manpower, so now we have big problem. We don't know what we have to do.
Ekuqaleni kwakunotshani, kunehlahla, silima, sikuthola ukudla, manje sekushile.
This area, all this area was a grassland. If you look now, you see is an encroachment everywhere. The changes is the trees and the grass, because when the trees take place, the grass dying underneath.
In 1994 we had 300,000 commercial farmers in South Africa. They're now down to about 30,000 and probably reducing quite rapidly. The problems they're facing are bush encroachment, and the challenge to South Africa is how we get small rural farmers into the economy so that they can start adding to the GDP of the country.
A proactive and reactive approach is required for the prevention and mitigation of the impacts of environmental change. Reliable knowledge is necessary for effective policy making relating to the management and use of South Africa's natural environment.
This facility behind me is unique and the first of its kind in Africa, and it allows us to increase the atmospheric CO2 concentrations within the chambers to simulate the atmospheric conditions that will occur in the future. Currently, the atmosphere is at about 400 parts per million. By the turn of the century, it will have increased to 700 parts per million, and we need to know how plants will respond to this increase in CO2 concentration. This is particularly important for our crop plants, but also for our indigenous plants that are becoming invasive or involved with bush encroachment.
South Africa's nature is changing. The reasons for those changes are complex. Much depends on whether farmers farm with sheep or goats, whether farmers use fire on the land, whether people chop down trees and use them for firewood or for other building purposes. But we believe there's an additional change, the change that's in the air, the carbon dioxide in the atmosphere, directly impacting our plants and altering all the ecological rules. And unlike our colleagues in the Northern Hemisphere, where global warming is this inevitable change, we can alter our future through careful use and clever, intelligent use of fire, browsing and herbivory. We can change the trajectories of how nature is moving. So let's do it.